What is up, guys? Fahir here from AwesomeTuts.com, and let us start making our level. Now, we saw in the previous video that we have materials and we have models, and I've showed you how that goes. So you create materials, you attach them on models and make them look great. Since we are gonna have a huge level, I have already prepared that level, and it is located in models, then military, and then prefabs. So we have the ground block main. Simply drag and drop it here, bam, inside of our level, and this is it. Now you see what I mean. Instead of us creating all of this, attaching it, dragging and dropping, and arranging, I've saved us a lot of time. Now you can go inside of here and you can then see what we have. So I have attached here a box collider on the asphalt block, as you can see here. So we have a box collider attached. You can, go and, inspect what we did. So you can go and inspect what we did. One difference that we have in regards to the colliders in a 3D game is that we are using a box collider. We are not using a box collider 2D. So when you filter here, box collider, you're not going to use the 2D one. You are going to use the 3D one. Now this is for our level. Let us duplicate this because I'm also going to import our military truck or the tank. And then we are going to create a collider for him and we are going to see that in action. So I'm going to duplicate the ground block main. And this one, I am going to position at 294 for the Z. Now, notice also one thing, that on the Z-axis, we are going forward. So forward is the Z-axis. You see here, going forward is the Z-axis. Going upwards is the Y, and left and right is the, X-axis. This is a little bit different in regards to our 2D games, because in a 2D game you can go forward and backwards on the X-axis, but in a 3D game you use, X, Y, and Z. So for example, if I move our, game object, as you can see here, to the left and right on the X-axis, he's moving left and right. If I move him on the Y, he will move up and down. And on the Z, he goes backwards and forward. So Z-axis is for, backwards and forward. Now, going inside of our vehicles here, we have our armor car, we have everything here. Let me just go and take a look at which one we are gonna take. So we are actually gonna take this one, Tank A or Tank 01A. So simply drag and drop this dude right here, and this is our tank. Now, as you can see, he is quite large for our level, which is, what we expected. But what we are gonna do is we are gonna resize him. So we're gonna resize him on his scale by taking, here, scale, we're gonna say 0.3x, 0.3y, and we're gonna say 0.3z. Now, as you can see in a 3D game or using 3D models, the Z scale matters. So the Z scale will matter in a 3D game. In a 2D game, it does not matter. But this is why I'm not telling you this, because the first two games that we did are 2D games. Now we're also gonna rotate him at 180 degrees so that he faces forward. As you can see, he is facing forward. Now this is what the camera see. We will fix that. Don't worry about it at the moment. So he is facing forward, and now we are gonna attach a box collider on him. Now, before we do that, we are going to create a parent. So right click, create an empty game object, which is going to be the parent of our tank. And we are going to name him player. So player tank 1, and put the tank as a child of the, player tank 1. And let me just put him at 0, 0, 0 for X, Y, and Z so that he is under his parent. And let me go here and drag him. Come on, I need to drag him. So take this dude and let me position him at 0, 0, 0. So yeah, 0, 0, 0 starting position. This is for the parent of our tank. Now simply drag and drop the tank as a child, but left clicking on him and dragging him under the player tank 1 game object. So what we are gonna attach on our player tank 1, we're gonna attach a rigid body. So not rigid body 2D. This is really, really important. When we deal with 3D games and work with 3D games, rigid body 2D, we are not gonna touch that. Nothing related to 2D we are gonna touch because it's a 3D game. So I'm gonna attach a rigid body, which is a rigid body 3D. simply named rigid body. 2D is for 2D. Now here for the constraints, I am gonna freeze the X, Y, and Z rotation. We saw an example of not freezing these in 2D games. So you saw that when the rotation is not frozen, he just starts to go around like he is, well, drunk. And when I say he, I mean our player. We are also gonna attach a box collider, not box collider 2D. Please pay attention to this, not box collider 2D, only box collider. So this one, the first one, you see even here, the icons, if I go here and take the highlight tool, which I cannot do because, well, now I cannot click on the component, but please take a look at the icons. For the box collider, the icon is a 3D cube. For a box collider 2D, it's a 2D cube. So take the box collider, this one right here. Now I'm not sure if you can see it because he is green. The box collider is actually green. Let me try to move him up. You see, I move him up. This is the box collider, you see? You see this right here? I think you can see it now. You see this box? I am gonna, well, quickly draw it. This right here, I think that you can see the box. Now this is the box collider. We of course need to resize it so that it fits our military tank. Let me just turn off our level so that we can see it more clearly. Here it is now, we can see it. Now for the size X, it is going to be 1.35. For the size Y, we're gonna say 1.1. Z size, it's going to be 2.55, and well, here I'm gonna simply set him at 0.59 for the Y. And for the Z, let me just take a look at here. Yeah, for the Z, we can maybe set that at negative 0.12, just so that we have a little bit space. So move that a little bit backwards, or move the collider a little bit back. Or actually it can be at 0. It can also be at 0. It's no big deal. Yeah, it can be also at 0. So you see now how the box collider is circled around our tank. So you see, it is circled, or actually it fills our tank, which means our tank now is collidable. If that is a word, well, collidable is now a word, so you can add that in your dictionary. Collidable, it means an object that can collide. And now we can collide with other game objects. I can put him back here, so I can put him back or put the level back. And if I run the game, we will see that our tank will not fall down, which is actually the case. Now, don't worry about the camera, which, well, the camera currently what it sees. So don't worry about that. We'll fix that later on. The important thing is that we have here our tank. Now, you see here that our level gets a little bit dark. Now, the reason for this is if you go into the Lightning tab right here. Now, if you don't see the Lightning tab, it is under Windows and then Lightning, and then you can click on Settings. So again, I said Windows, it's Window. So Window, Lightning, Settings. When you click on that, you will see this right here. It will probably be floating. So it will be floating. Can I make it float? Let me see. Yeah, I can make it float finally. So it will be floating, something like this. You can put it wherever you want it to be. I put it here where my inspector panel is, so right next to it. Since Lightning takes a lot from performance, even during development. When you go into the Lightning, you will see here you have 3 tabs: Scene, Global Maps, and Object Maps. In the Scene map, here at the bottom, you have something called Auto Generate. If I take the highlight tool, I'm gonna highlight it so that you can see where it is. You see, this is that Auto Generate that I was talking about. This right here. Now, it is turned off for a reason, because if I turn it off now, you will see we have Lightning back. But this rebakes light. Every time we move a game object in a scene, it will try to calculate the light on that game object, which will slow our computer down. So we don't want to do that. For you, by default, this here will be checked like this. But I just wanted to explain why don't you see lights in a game or in the game, because previously we have saw lights when we first started to work. So if I turn them off, well, it can happen that we don't see lights in our game as we did a moment ago, but for a reason, because when you turn this off, this auto generate, that means that Unity will not try to rebake the lights, and it will save performance for our computer, which is, well, great if you want to work a little bit, well, with your computer. Otherwise, if you don't and you want to make him laggy, then you can turn this on. So again, Window, Lightning, Settings, and then here in the Scene tab at the bottom, you can click or turn off this Auto Generate. It is at the bottom, so turn it off. Automatically generates light data in the scene when any changes are made to the lighting system. This means even if we change any game object, move him, so on and so forth. It will try to recalculate the lightning on that game object, which makes our game go a little bit slow. In the prefabs folder, which we already have because we have imported, here we are gonna go and create a new folder, player, prefabs. Here you can put your tanks. You can have multiple tanks. We have player tank 1, which is this dude right here. I'm probably not gonna add more tanks in the game, but you can go here in the models, military, and then prefabs, vehicles, and then you can add whichever vehicle you want. We need to go in the inspector tab. You have tank B, C, you see you have other tanks here, other vehicles, so you can add them and then attach the scripts that we are gonna create. Now for this video, we're still not done. We're gonna prepare one script, which is pretty easy. So we're gonna go create a scripts folder. Inside of the scripts folder, we're gonna, well, right click again and create a new player scripts folder. And inside of the player scripts folder, we're gonna create a C# script that we are gonna call base script. This base script or base controller, so base controller is going to be the dude that's gonna hold some information that we are gonna use with the player controller to actually move our tank. Now we are also gonna add an audio source component on our tank. So audio source, so make sure that you add that. We already saved him as a prefab. So hit apply. Here, hit apply so that these changes apply to the prefab. As you can see here, when I select player tank 1, here we have rigid body, box glider, and audio source. When I double click the base controller, it will open, well, the base controller in MonoDevelop, hopefully, or hopefully not. So let me just go here and try to open it again, because sometimes Unity, well, does this to me. And bam, here we have it. This is our base controller. So here I'm gonna say class, tag it as a class. Our base controller is gonna inherit from Mono behavior, and we need, as always, a couple of variables. Now we need a public vector3 speed. This is going to determine the speed of our vehicle or our tank. We also need a public float x_speed, which is going to have value of 8, and z_speed, which is going to have a value of 15. X speed will be the speed moving left and right. Z speed will be the speed moving forward and backwards, or actually just moving forward, because we're gonna use another variable to slow down. Anyways, the Z speed will be going forward. So this is the speed going forward. We are also going to have a public float accelerated, so accelerated, which is gonna have a value of 15, and deaccelerated, so deaccelerated. Did I write it right? Accelerated, deaccelerated. Yeah, I think I did. Which is equal to 10f. If I misspelled something, sorry for that, and I do not care, okay? Anyways, this variable will be the speed when moving forward and moving, or slowing down and moving backwards. So actually, we are not gonna move backwards, but we are gonna slow down. And while we are moving faster forward, when we slow down, well, this is going to be that speed. Deaccelerate. So accelerate means add gas. Deaccelerate, well, release gas so that we can go a little bit slower or even break down a little bit. We are also going to have here a protected, so protected variable float rotation speed, which is going to be equal to 10f. Now, a protected variable is like a private variable, but it can be accessed, or the protected variable can be accessed in a child class. What is a child class? Well, go into the C# section where we talk about classes and inheritance. We are going to inherit this base controller class in our player controller, and we're going to have these variables. Protected means it will be accessible inside of the child or the class that will inherit the base controller. So our rotation speed is going to be protected, and also protected float maximum angle is also going to be a protected variable. So here we're going to say, well, 10 for the maximum angle that we can rotate. And we are going to have here a public float for the low underscore sound underscore pitch, like this. And I'm going to copy the name. Copy the name is going to say comma. This is going to be normal sound pitch. And this is going to be our high, so high sound pitch. Below, we are going to have public audio clip, which is going to be engine on sound and engine off sound, like this. And of course, we will need a private bool. So private bool is slow for, well, for us to determine if we are going slow or not. Now, this is only a preparation for our player class. I will go again briefly what these variables are. So the speed is going to be the overall speed. This is a vector3 variable because we're going to move our game object by using, well, using the rigid body, and we're gonna apply speed to the rigid body. The x speed is the speed moving left and right. Z speed is moving forward. Accelerated is when we start to move forward faster. Deaccelerated when we break down. Rotation speed is the speed by which we will rotate. Max angle is the maximum angle by which we can rotate. Low, normal, and high sound pitch are going to be used in combination with our audio source to, well, simulate the engine sound of our tank. Audio clips, engine on and off, they're going to be those sounds. Is slow will determine if we are going slow or not. Now, in the awake function, we are going to set things up. So our speed variable is going to be equal to new vector 3. 0 for the x, 0 for the y, so 0f, and z speed, so z underscore speed for the z speed, because we're gonna move forward as soon as we start the game, but we're not gonna move left and right. Now, we are also gonna have here protected void move left. So here we're gonna move left, and what we are gonna do here is simply call our speed, which is going to be equal to new vector 3. It's going to be the negative x speed divided by 2f, 0f for the y speed, and z speed here. Now, what is this here? We're simply adding, or this speed variable, which is this one on top, that I said we're going to use it in combination with the rigid body to move our game object. So we will see that in the next video. If we move left, we are going to the negative side. So negative of the x speed, divide that by 2 because we don't want it to go too fast, and the z speed is for pushing us forward. Now here we are also going to have move right, which we are going to do the exact same thing, but to the right side, so move right, but here it's not going to be negative, it's going to be positive, because we are moving to the right side, as you see. So the right side is the positive side on the x-axis. Y-axis will be 0 because we're not going to move our tank up and down. We are also going to have here move straight, so straight like this. Here we are simply going to remove this, so remove for the x, it's going to be 0f comma 0f for the y, and the z dot speed. So here we're going to say speed dot z for moving, well, for moving forward. Now also, excuse me, here we're going to say speed dot z, and here also we're going to say speed dot z, not the z speed, but speed dot z. But for the x-axis, we will use here, so we will use negative x speed, and also here positive x speed. But for the z, it will be speed, which is this right here. This, the speed variable that we already have. Now this is for moving straight. We're also gonna have move normal. So here we're gonna say protected void move normal. What is move normal? Well, here we're gonna test if is slow like this. If we are going slow, so after we call move normal, if is slow is true, we are gonna say is slow is now false, so we are not moving slow anymore. Audio source is going to be equal to sound manager, so sound manager like this, which is going to be equal to get component, and here we're gonna say audio source component. Now instead of us doing like this, we can simply go here on top, and right here below we can say private audio source sound manager, and in the awake function we can simply say sound manager is now equal to get component, so sound manager, I wrote it with manager, so sound manager is equal to get component. So here what we are going to do is call the sound manager and say stop, because first we want to stop the audio. Then we're going to say dot clip is going to be equal to engine on sound, and our volume is going to be equal to 0.3f, and we're going to call him to play the sound. And below here So below our move normal, we are going to call our speed, which is going to be equal to new vector 3. And here we're going to say speed dot x for the x-axis, 0 for the y, and for the z, it's going to be underscore or z underscore speed. This is for moving normal or moving using our z speed. Now we are also going to have move slow, so protected, void move slow. In move slow, we are going to test if we are not moving slow. So if we are not slow, as you can see here, we have an exclamation mark, which makes what's after it the opposite. So if is slow is false, this right here will make it true. If we are not moving slow, then is slow is true. So now we are moving slow. We're going to call our sound manager. So sound manager to stop like this. Actually, I'm going to copy all of this here. So sound manager is first going to stop. Then we are going to attach to him the engine off sound. Then the volume is going to be 0.5. Then he is going to play. Now here for the speed, so speed is going to be equal to new vector 3. For the x, it's going to be speed.x, of course 0 for the y, and deaccelerated for the z because we are now gonna move slow. So deaccelerated will be for, well, for our game object or the speed of it. As you can imagine, we have move slow. We will also have void move fast. And in move fast, we're simply going to take all of this here, like this, and we are going to say accelerated. So we're simply going to say accelerated. Now you can also put this right here, so you can put, or actually this from move normal. Yeah, from move normal, you can put it right here if you want. I will probably not do that, but you can also do that if you want. Now this is the preparation for our base controller. Notice these functions are also protected, which means we can access them in the child classes, which will allow us to, well, it will allow us to use them in the child classes. So again, we have here the speed variable, which is the overall speed. We will use this speed inside of our child class in combination with the rigid body to move the game object. So when we first start our game, we will get the audio source or sound manager, audio source. We will set the initial speed. So speed is 0, 0 and z speed for the z speed because we want to move forward. Moving left, we'll set the speed to negative x speed divided by 2. So then we will move left. And the speed dot z, which is for moving us forward. For the right, x will be not negative, it will be positive, divided by 2, 0 for the y, and speed.z to move us forward. Move straight, only speed.z so that we can actually move, well, straight or forward. Move normal, it means after we are moving slow, we will move normal. So if we are moving slow, you see here, if is slow is true, we are moving slow, is slow is false. Stop the sound manager, add the new clip, set the new volume, and play the sound. And the speed is, well, adding here the x speed and the z speed. This is speed.x. So we are getting the speed from here, but the z speed is our normal speed. Move slow. If we are not moving slow, then here is slow will be true. Stop the sound manager, change the clip, change the volume, play it. Speed. Speed.x, we will set the speed.x from the current x speed, and here it will be deaccelerated, which means slow down. Move fast, simply, well, speed.x, and here accelerated for moving fast. So we did quite a lot in this video. We created our player tank, we attached a rigid body and a box 3D or a box collider, which is not a 2D, which means it's a 3D one. We talked about the difference between them. If you attach a box collider 2D on this, it will not work. So your game will not function properly and you will see errors and trouble and whatnot. Also for the rigid body, it needs to be rigid body, not 2D, but rigid body. And you can inspect the ground that I have created here. So you can inspect it on your own, how I attach these box colliders, what you have all of here. I've just saved us a little bit time so that we don't have to create all of this here. It will be, well, troublesome for us to create or recreate everything that you see here. And we also prepared the base class, which is this bad boy over here, which we will inherit in the next video and make our game object or our tank move forward. Fahir here from AwesomeTudes.com. I will see you guys in the next video.